there's lots of stuff out there that calls itself SQL and Hadoop.
There is.
And you talked about what that broadly meaning as having SQL query capabilities on the one hand and running on the Hadoop stack as its underpinning on the other hand. But it goes deeper, right? There are some databases that just give you a SQL syntax, but they're not full relational. Even if they are full relational, they're not transactional, as you were discussing before. And then there's different parts of the Hadoop stack that you could run on. You're actually running on HBase, which is a NoSQL database. So you are a full-scale relational database running on a NoSQL database.
That's exactly right. I couldn't have said it better.
Why did you? It's all well and good that I can identify this, but why did you guys decide to go that way? And doesn't that lead to some architectural, kind of conflicts? And how'd you overcome those, or did you even need to?
Well, we knew when we started we wanted to build an operational database that handled both OLTP and OLAP workloads. That meant that we had to be able to do real-time updates.
Can I be the acronym police? So OLTP
Absolutely.
being transactional, kind of operational stuff, and OLAP kind of means different things. It's kind of a category of products, but that's not really what you mean. You just mean analytical processing.
Correct.
So the T is transactional, the A is analytical.
That's exactly right. And so we knew that we wanted to be able to handle the transactional piece in particular, and that was going to be new.
Right.
And Hadoop isn't well architected for that, or at least traditionally, people didn't think of it as being well architected for that. But what the Hadoop community did is build a key value store that allows you to do real-time updates. And that key value store was designed after Google's big table, and that was HBase.
Right.
So HBase gave us the ability to do real-time updates of values stored on the Hadoop infrastructure, and even gave us a transactional semantics, or kept consistent updates when they were on one table in one row. So it was a nice building block for us. Otherwise, we'd have to build all that. So yes, we built on HBase. It provides us that transactional capability for changing individual key value records in a table, but then we built around that. And so it was a good choice for us, and we're seeing it scale nicely.
And I guess if even the incumbent relational databases are really just built on a file system, then arguably building on a NoSQL database is starting with a more structured kind of fabric to begin with.
Right, it's an API that makes sense for operations. You can get a record, you could scan a range of records,
Right.
You can write a record, and delete a record. So it's a very simple API that we can base all of our transactional activity upon.
All right, and you get the same kind of commodity hardware, maybe more important, commodity storage that anything with Hadoop involves. And as you were saying, you're building stuff based on adding inexpensive nodes instead of adding expensive resources to a single machine.
That's right. So, for example, our first customer is a company by the name of Hart Hanks. Hart Hanks is a marketing agency and marketing software company. And they have an omni-channel campaign management solution, not unlike the things we built back in the day at Blue Martini, that they service many different retailers and financial services providers, automotive providers with. And they had a stack of software that was a state-of-the-art campaign management stack. It used tried and true software. It used IBM's Unica application. It used Cognos for reporting. It had Ab Initio for ETL processing. And then Hart Hanks has a division called Trillium, which basically dedupes and does householding types of transactional work. And all of this was powered on Oracle. And Hart Hanks was out in the marketplace looking to solve a particular problem because their Oracle instance powering these campaign management and campaign marketing solutions was really grinding to a halt. And they were literally thinking about throwing away the whole software stack and writing it all in NoSQL. And so germane to our conversation about SQL versus NoSQL. And we said to them, don't do it. And we said, you can keep your entire stack of software, but just replace the Oracle RAC system with Splice Machine's relational database system. And they said, there's no way that can really work. And we said, we'll prove it to you. And the reason why I tell you this story is because it gives you a feel for the cost comparison between the different architectures. Just in that case, we were able to show on the queries they gave us almost 7 times performance improvements at a quarter of the cost that they were using today, let alone what they'd have to scale up to be able to handle the kinds of volumes that they wanted to get to. So I think literally when you compare the scale-out architectures, not just Splice Machine, but scale-out in general,
Right.
you see the difference between hundreds of thousands of dollars for a really scaled database versus many millions. And so it's a fundamental difference for the enterprise.